Good morning, everyone. Am I clearly audible?
Yes, sir.
Am I audible to everyone? Only one person is answering. Am I audible
Yes,
to
sir.
everyone?
Yes, sir.
Yes.
Good morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning, sir.
So today we are not going to waste much time. So as I said from this class, everybody has to be attentive. Okay, now onwards I will not ask it 2-3 times whether you have doubts or not, whether you have doubts or not. Okay, you have to be quick enough. In one go you are supposed to give the answer. Okay, if anybody will be having doubt, definitely I will be solving it, and we will not go further until your doubt is not clear. But if you are not asking, that's going to be your problem. Okay, fine. So let's start with this. How much we have done till yesterday? Is my screen visible to everybody?
Yes,
Yes,
sir.
sir.
Yes, sir.
Good. So now moving on to this, what we have done till last class we were doing this minimization of DFA, and we have learned these unreachable states, and we have learned what are the duplicate states. And after learning them, I have given you one diagram, and we are going to minimize this particular automata. All right, and this is going to be the algorithm. I hope, as I told you, that everybody should read this algorithm carefully. So I hope everybody must have read this algorithm. Have you found my yesterday's lecture in your student account? Yesterday, in fact, I guess yesterday there was no lecture. So till the last lecture, everybody have got the lectures. Recording of recorded lectures are available to everyone.
Yes,
Okay, whenever you want, you can access them in your student account. And if you have any kind of doubt, then what we can do is, in whole week, we can fix one class, whatever day you want, either Friday, either Tuesday, Wednesday, Monday, whatever day you all of you combinedly choose, that day we can choose, and that day will be for the doubts only. Let us say whatever the lectures I have given all over the week, I guess the last class, whatever is the last class, that is best, because what you can do is, whatever doubts you are remaining in whole week, so on the last class, first we will spend some time to clear those doubts, and after doing that, we will start our new content for that particular class. All right. So if you want, we can do this. No problem. Now let's begin with this. So this was the algorithm which we are supposed to implement. Okay, so now we will be implementing this. So first of all, we are supposed to remove the unreachable states, and for unreachable states, I told you, not only remove the unreachable states, rather you also have to remove the paths from the unreachable state as well. Okay, so first let me give you this, let me copy this particular slide, and in this copied diagram I will shift it somewhere at this point. Fine. So can somebody in this diagram tell me, do you find any unreachable states?
Q3.
Q3, sir.
Q3 is unreachable, right? Because there is no incoming arrow going inside the Q3. So what we are supposed to do, tell me, according to the algorithm, we have gone through with the algorithm. So what we are supposed to do in this case?
Remove Q3 as well as outgoing edges.
Remove those states.
Correct, correct, very correct. So we have to remove Q3, and we also have to remove the outgoing edges from Q3. So this part should be removed. Now again we have to check, is there anything else now which has become unreachable? Now can you please check once again, is there any more state in which there is no incoming arrow? Check it out and tell me.
No, sir.
Everybody check this. Is there any more state in which now there is no incoming arrow?
No, sir.
No, there's no such kind of state. That means all unreachable states, that is step 1, all unreachable states are removed. Fine. So what we can say, that this part, the part what I have written from the red pen, now this is finished, nothing remaining. Okay, so now what we are supposed to do, we are supposed to come on to this second part where we are having finding and removing duplicate states. So for this, what we have to do, convert the given transition diagram into transition table, and you are already aware about what is transition diagram and what is transition table. So you are already having your notebook and pen, you must be. Is everybody keeping? Do
Yes,
everybody
sir.
have notebook and pen?
Yes, sir.
Yes, sir.
Yes, sir.
Good, very good. So there is your diagram, okay, and you are supposed to convert it into the transition table. So make it as soon as possible. Start doing this. I'm putting myself on mute, leaving you with this diagram. Convert this into the table, and as soon as you convert it, put a done sir into the chat box. Everybody have done? Anybody who have completed? Fine, make it fast, do it fast. I'm just changing this slide. So what you do, take a screenshot out of it, and from that screenshot you make that table on your notebook. Take a screenshot quick. Everybody have taken screenshot? Guys, reply me fast. Everybody
Yes,
have
sir.
taken screenshots? Fine. I'm just starting a new slide. Yes. So now tell me, from Q0 to A, where we are going?
Q5.
There we are moving to Q5. Okay. From Q0 to B, where we are going?
Q1.
Q1.
Fine. The next one. From Q1 to A.
Q2.
From Q1 to B.
Q7.
From Q2 to A.
Q2 itself.
From Q2 to B.
Q0.
Fine. Next, somebody else should say. From Q3 to A, where we are going?
Sir,
Sir,
Q3,
Q1 to B is wrong, sir.
we remove it.
Q2 to B is wrong.
Q1 to B.
Q1 to B. Rectify this. Where we are going?
Q6.
Q6, sir.
Q6. Who said Q7?
Me, sir.
Check your answer, dear. Check once again. Q3 to A, where we are going? Q3 to A. Be fast.
Sir, we removed Q3.
We have removed Q3. Fantastic. So there should not be any space for Q3 as well. I'm not removing this thing. Just consider it empty. Okay. We are not supposed to write this for Q3. I forgot that we have removed this state. So that's why. Okay. Fine. We are writing now. Q4 to A.
Q5.
Q5.
Where Q5? Is it Q5 or which one?
Q5, sir.
Q5, sir.
Q4 to A. From Q4 on A. Yes, Q5. Next one is Q4 to B. Where we are going?
Q7.
Now Q5 to A.
Q4.
Q5 to B.
No, sir.
Q2.
Q5 to A, it's Q6.
Don't get this wrong. Q5 to A, it is Q6. Who said Q4?
I said that, and I know that it's wrong, so I told you it's Q6. Sorry,
Be
sorry.
careful. Be careful. It's Q6 now. Fine. Q5 to B. Where we are supposed to go?
Q2.
Be fast. Q2. Fine.
Q2.
From Q. Okay. From Q7 to A.
What about Q6, sir?
Definitely. We are. Yes. You are right. We are supposed to write here Q6. So Q6 must be there. Okay. So from Q6 to A.
Q4.
Q4.
Q4. And Q6 to B.
Itself.
Q6.
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 Fine. Next one is from Q7. So from Q7 to A.
Q2. Q2.
Q2.
sir.
And from Q7 to B.
Q6.
Q6. So that's how. See, I'm not cross-checking this table. I hope everybody is getting the same table.
Yes, sir.
Yes, sir.
Is everyone getting
Yes,
same?
sir.
Yes, sir.
Yes, sir.
Perfect. So now what we have to do, we have done with this particular step. What was the step? Convert the transition diagram into transition table. What next we are supposed to go for? Divide transition table into two parts, where in first part we should carry all those transitions which are starting from the non-final state. The only final state is what? Q2. Yes or no? The only final state is Q2. So this is the only final state. and there is only one transition which is starting from Q2. Rest of all other transitions are starting from all the non-final states. So what we are supposed to do now, we are supposed to make it into the two parts. In one part we will keep only this Q2 transition. Why we are keeping only one transition? Because we have only one such transition. If multiple transitions would have been there, then definitely I would have been kept multiple such transitions into the second part. Okay, and here all other transitions will be kept. Yes or no?
Yes, sir.
Yes, sir.
So very quick, within next 2 minutes, immediately divide this table into two parts. Separate this transition from this table, and rest of the transitions should be written as it is. Make it fast. Come on. Everybody have finished?
Yes, sir.
Good.
Yes, sir.
So let me write these two tables on a next slide. Let me write it onto the next slide. Q0, Q1, then we are supposed to write Q4, Q5, Q6, and Q7. Let's have it for A and let's have it for B. Fine. Tell me this one.
Q5, Q1.
Q5, Q1. Next.
Q2, Q6.
Q2, Q6. Next.
Q5,
Q5,
Q7.
Q7.
Next.
Q6, Q2.
Next.
Q4, Q6.
Next.
Q2, Q6.
Fine. So that's what we have got in the first part, and the second part contains Q2. From here we have A, from here we have B. What we have to write here?
Q2 and Q0.
Q2 and
Q0.
Q0. Fine. So everybody must have got this two tables, right? Now what we are supposed to do, we are supposed to implement the step 3. After dividing this, what we are supposed to do? Remove the duplicate rows from both divisions of transition table and replace the replica state by original state. Now let me tell you how to do this one. what you have to find out, you just have to check that in the last two columns, right? Remember, in the last two columns, where you find a duplicate row, is there somewhere? Is it somewhere? In the last two columns,
Q1 and
in these two
Q7.
columns, is there some duplicate row? Everybody check, and
Q1 and Q7.
everybody else also reply. What two are the duplicate rows?
Q1 and
Q1 and
Q7.
Q7.
Q1 and Q7.
That means Q1 and Q7 are duplicate states. These are the duplicate states. So we are supposed to carry any one of them, and we are supposed to remove any one of them, right? Whatever you want, you can choose. But since everybody stays symmetric in the class, so that's why, as if now, just choose Q7. Otherwise, if you want to remove Q1, you can remove Q1, no problem. If you want to remove Q7, you can remove Q7. There's no such restriction. Okay, so what you are supposed to do, you are supposed to remove any one of them. So what I can do, let us say that this particular state will be removed. Okay, this is removed. So that means what? Now in place of Q7, there is no Q7. In fact, there is Q1 only. In place of Q7, now what we have? Q1 only. Yes or no?
Yes, sir.
Yes, sir.
Only two people are replying. What about others? Are you getting this thing or not? Everybody reply fast.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Good. So now wherever you see Q7, that should be replaced by Q1. So in these two columns, anywhere if there is Q7, let me know. Tell me, where is Q7?
In third row. Q4. Q4.
This one. So in spite of this Q7, now I am supposed to have Q1. Yes or no?
Yes, sir. Yes, sir.
Let me draw it a little more clear. So now I am supposed to have Q1. Okay. Now again you have to check. Are there some more copied rows? Check out.
Q0, Q4.
Q0 and Q4.
Q0 and Q4.
Q0, Q4.
They are again copied. So what you can say that Q0 and Q4 are duplicate states. Basically, they are replica states of each other. So these are the duplicate states. Any one of them should be removed. Again, you have to choose which one you want to remove. That's your choice. As if now I am removing Q4. Okay. So we are supposed to remove Q4 from this place. And wherever, okay, wherever Q4 is written here,
Q6, sir.
yes, Q6 was copy or this was copy? Q4, Q5, Q1, Q5, Q1. Yes, Q0 and Q4 is copied. Somebody was asking about something about Q6. Who was asking?
No, no, sir.
Anything you want to ask, Ahmed?
No, no, sir.
Okay. So now again you have to check. In spite of Q4, what we are writing? Q0 only. So check this carefully. Anywhere here, is there something Q4 written?
At Q6.
At Q6, A transition, we have Q4. So in spite of this, what I'm supposed to write here?
Q0.
Q0. Here we are supposed to write Q0 because we are removing Q4. So until now, as duplicate states, what we have removed? Q7 and we have removed Q4. Now again you check. Is there anything again copied?
No, sir.
Now nothing is copied over there. Okay, so what we are supposed to draw, we are supposed to redraw these two tables. See, the similar process should be applied in this section also. Particularly for this question, fortunately we have only one row. That's why there is no application of this process, because there is only one row. If there would have been multiple rows, then don't end up your process just by applying it on the first part. The similar process which you have applied on the first part, that same process you have to repeat for the second part in case if it is having multiple rows. Okay, and once both minimized tables are there, then you are supposed to merge these two tables once again. So can you please merge now? Everybody do this. Merge these two tables. Quick, be quick. Merge these two tables. I'm putting myself on mute. You just merge it. And once it is done, then type a message, done sir, in the chat box. Everybody have done with this?
Yes, sir.
Good.
Yes, sir.
So
Yes, sir.
Yes, sir.
Can I have the tables, please? Yes, tell me what I'm supposed to write. Q0, then
Q1,
it's A, it's B. Yeah. So from Q0 to now start saying rows. Q0, then
Q5, Q1.
Q5, Q1. Next,
From Q1, it will go to Q2 and Q6.
next,
Q2, Q2, Q0.
next. Somebody else also say, not only one person. Everybody participate in this activity. Yes, next.
Q5,
From Q5
Yes,
to Q6 and Q2.
Q6 and Q2. Good. Next one.
From Q6, Q0 to Q6.
Q0 to Q6. Anything else?
no, sir.
Fine. So which one is supposed to be my final state?
Q2.
To itself.
Q2.
And which one is supposed to be my initial state?
Q0.
Q0. Can you draw a transition diagram out of it?
Yes, sir.
Yes, sir.
Make it fast. Make it fast. Make it fast. Very quick. Draw the transition diagram.
It's down, sir.
Yes. Fine. So let's draw the diagram here. Q0 supposed to be initial state. Yes. So from here, one arrow for A. Which state I should mark here? Tell me fast.
Q5.
Q5. Final or non-final?
Non-final.
Non-final.
Non-final. On B, where I'm supposed to go?
Q1.
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 Non-final or final?
Non-final.
Non-final. Perfect. From Q1, where I'm supposed to go?
Q2.
Q2. Final or non-final?
Final, sir.
Final.
Final state it is. Perfect. Now from B, Q1, where I'm supposed to go for B?
Q6.
Q6. Final or non-final?
Non-final.
Non-final.
Good. Very good. From Q2, where I'm supposed to go?
Q2 itself.
Q2 itself for A. And for B, where I should go?
Q0.
Q0. All right. Next, from Q5, for A, I'm supposed to move to Q6. And from B, I'm supposed to
Q2.
move to Q2. Good. And now from Q6, for A, where this symbol is, I've written
Q0.
this should be what? Symbol should be what? Q2 to Q0. When we are moving, the symbol is B. Fine. From Q6, I'm supposed to go to Q0 for A, and here there should be a self loop. So this is what your minimized DFA. Is that clear to everyone?
Yes, sir.
Yes, sir.
This is your minimized DFA. Fine. So everybody just go through with this once more on yourself, and if you find any problem in this, then ask me now. Is everybody comfortable enough with this one?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Fine. So now after this, we will move to the new topic. Lecture is till 12:10, right?
Yes, sir.
Fine. So still we have 20 more minutes. Are we finished with NFA to DFA conversion? So we have done with NFA to DFA conversion. Now the new concept which we have to go through with is NFA with epsilon transitions. You have to go through with NFA with epsilon transitions. Now let me tell you what is this NFA with epsilon transitions. Okay, in automata epsilon means null. Okay, in automata epsilon means null. That means even without passing anything, we can move to some other state. So definitely it is not possible with the DFA. It is possible only and only with NFA, right? It's definitely not possible with DFA. All right. So first let me draw one diagram for you, which is showing the NFA with epsilon transitions. Once I am done with this diagram, everybody please draw this diagram on your notebook also. Once I am finished doing this, you should also do this because it will be useful diagram for you. Whenever you will be referring your notes, this will help you a lot. Now it is finalized. Everybody draw this diagram on your notebook. Draw it. Everybody have drawn this?
Yes, sir.
Fine.
Yes, sir.
Yes, sir.
Good enough. So now what we are supposed to do, we are supposed to learn that how to remove epsilons from this. First of all, let me tell you what is the meaning of epsilon. So as I've told you that epsilon means nothing. So empty string in automata is represented by two symbols. One is this epsilon and one is this one also. Eventually these two symbols are same. Any of the one can be given into your exams, okay, for asking questions. So these are the two things which we are supposed to remember. Now epsilon means what? As I told you that it is nothing. So that means what? On Q0, if I pass nothing, or nothing means epsilon, if I pass epsilon or if I don't pass anything, even then I can move to Q1, right? In the same way, on Q1, if I pass nothing, even then I can move to Q2, right? Even without passing anything, you can move these states. This is possible only in NFA. In DFA, it's not possible, right? Now, what we have to do with this, basically, this is considered as one of the, you can say, impurity kind of thing. So it is also one of the impurity. Impurity does mean it is undesirable. Ideally, one finite automata should not have any epsilon move. It should be having defined moves. All right. What is the reason why it should not have any epsilon move? The reason behind it, because epsilon can be anywhere. For example, let me tell you this. There's a string called, let's say, AAB. Okay, AAB. There's a string called AAB. Now, what is the problem with this? What is the problem with epsilon automata? It is AAB, that's okay, but it can also be written as A epsilons, any number of epsilons, then again A, then again epsilon, and then again B. Are these two things are equivalent or not?
Yes, sir.
Yes, sir.
Yes, sir.
Definitely they are equivalent, because here what we are saying, that between A and this A there is nothing, and here also I'm saying between A and A there is nothing. Now what is the problem? The problem is, if you consider this diagram, then after 0, if I consider one epsilon, then path will be changed, because after 0 it is let's say if I have this 0 0 1, then on first 0 it is supposed to be on 0, on the second 0 it is supposed to be on 0, but if I consider epsilon between them, then what will happen? After first 0, on this epsilon it will move to Q1. So that's the ambiguity. Getting the point? This is the ambiguity. Ambiguity does mean what? Ambiguity does mean, you can say, some error or redundancy. So that's why it is not able to find out on a particular symbol that where I am supposed to move, either to Q0 or Q1. This is the problem, and that's why we have to learn that how to remove epsilon transitions. We have to learn how to remove epsilon transitions. Got the point? Everybody have got this?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
So now we have to find out that how to remove this epsilon, and for doing this I'll tell you the steps. Okay, for performing those steps, first I want to make this diagram on another sheet. Fine, let me keep it to this. I'll draw it once again. Let's draw this diagram once again. Q0, from this I have got epsilon. Q1, from this I have got epsilon. Q2, there I was being on 0 and 1. So this is 0 and this is 1. And here also I am on 0. Yeah, fine. You can consider it either for 0 or for A or B, or for B or for anything. Okay, since you have been comfortable with AB, so let me write here AB. Any one of the input symbol can be mentioned. There's no restriction on that. So just let me rewrite this in the form of A and B. So here we have A, here we have B, and here we have C. Let's introduce a new symbol called C. So when you are doing this, first what you are supposed to do, first you are supposed to find out the epsilon closure, epsilon closure of every state. Now point comes, sir, what is the meaning of this epsilon closure? So what is epsilon closure? For example, epsilon closure of Qi is what? Set of those states on which you can reach from Qi by passing epsilon only. That's the simple meaning of this. Okay, there's nothing difficult. The simple thing is, what will be epsilon closure of any state Qi? That it simply gives you set of all those states where you can reach from that particular state just by passing epsilon. That is supposed to be the epsilon closure. So for example, if I check out this, if I ask you this thing, what shall be the epsilon closure of, what shall be the epsilon closure of Q0? So just look at the diagram and tell me, from Q0 if I pass epsilon, obviously Q0 will remain there. Q0 will definitely be there, because on Q0 if I don't pass anything, I can stay on Q0. Yes or no?
Yeah.
On Q0 if I don't pass anything, I can stay on Q0. Now from Q0 if I don't pass anything, okay, then to which state I can reach?
Not yet, sir. It will be unreachable. You will be unreachable.
Why unreachable, dear?
I think now
On
there is no
Q0, wait,
on Q1.
on Q0 if I don't pass anything, this epsilon is nothing or not? This epsilon is nothing or not? This epsilon is
You don't
representing,
remove it or what?
this epsilon symbol is representing a nothing. Yes or no?
Yes, sir.
Yes, sir.
Am I right? This is representing nothing. So on Q0 if I pass this nothing, then can I reach to Q1 or not?
Yes, sir.
Yes, sir.
I can reach to Q1. On this if I pass nothing, I can reach to Q1. Okay, now from now I have reached to Q1. Now I am on Q1. Now from Q1 itself if I pass nothing, I can reach to Q2 or not?
Yes, sir.
Yes, sir.
Definitely I can reach to. All right, so from Q0 if I don't pass anything, I can go up to Q2. Yes or no?
Yes, sir.
Is that clear to everyone?
Yes.
Yes, sir.
Similarly, epsilon closure of Q1 will be what? Tell me.
Q1 and Q2.
Everybody is not clear for this. Fine. Let's do one thing. Let's take this topic into the next class. Okay. We cannot complete this one in this class, so let's take this topic for the next class. We'll take it further into the next class. Okay. First, let's mark the attendance for today's class. So let me take the attendance. Everybody, please make sure to mark your attendance in just one go. Okay. This is TD1 and TD2.
Yes, sir.
Yes, sir.
Class timing is 11:10, right?
Yes, sir.
Fine. TD2 is coming first. SPT. Okay. TD2. First I'm taking for TD2, okay? Sabis Soti, 4012, 4017, Lina Hassan,
Savishwati present, sir. Savishwati present.
Lina Hassan, fine, marked it. Lina Hassan, Hassan Noman,
Yes, sir. And
4020, Elias, Hala Mahmood, Tawfiq
Present, sir.
Ahmad Tushar, okay. 4023, Muhammad Osama, 4024, Muhammad Hasim,
Yes, sir.
4025, Ibrahim Inusa, 4026, Agihat,
Present, sir.
4028, Ibrahim Sharif,
Yes, sir. Present.
4031, Hiba,
Yes, sir.
4033, Dhara,
Yes, sir.
4036, Maya Hassan, 4038, Nweke,
Present, sir.
4039, Yarob,
Yes, sir.
4040, Alhait,
Sir, 4036.
who is 4036? Maya Hassan,
Yeah.
4041, Haider, 4044, Angam Saad, 4047, Ali Kamal Mehboob, 48, Hussein,
Yes, sir.
49, Haider, 4051, Waha Osama Khador, 52, Adam Nasir, 53, Ibrahim Hafiz, 54,
Yes,
Ahmad,
sir.
55, Ahmad Ali Yusuf, 56, Ali Zulfikar, 57, Ibrahim Firas, 58, Anas, 59, Yusuf, 59, Yusuf Kiseber, 60,
Yes, sir. Here.
59 is present or absent, 61, Isa,
Yes,
Isa
sir. Present.
63, Mahmood
Present,
Yasir,
sir.
64, 6-4. Be quick. Ahmad, Akram. Fine. Anybody remaining? Speak your roll number. Don't put it into the chat. Is there anybody remaining? Say your roll number.
Sir,
Yes. Yes.
Sir, this connection is very bad. It's 56. Ali Zulfikar.
Ali Zulfikar. 56. Fine. Anybody else? This is the last time I'm asking. Already I had to do one undo. Fine. Done with this. 56 I have marked. Ali Zulfikar.
thank you, sir.
Fine. Now from TD1. Everybody from TD1.
Excuse me, sir.
Yes.
For TD2, can we leave?
Yes, definitely.
Okay, thank you,
TD2
sir.
people can leave. No problem.
Thank you.
Now from TD1. Roll number 14. Kushal.
Present, sir.
Roll number 4080. Deepak
Present,
Kumar.
sir. Present, sir.
Roll number 2. Dhruvil.
Present, sir.
3. Hasti.
Present, sir.
4. Bansi.
Present, sir.
8. Nancy.
Yes, sir.
9.
Yes, sir.
Mansi. 11.
Yes, sir.
Utsav.
Yes, sir. Yes, sir. Present. Utsav.
13.
Present, sir.
14. Jay.
Yes, sir.
15. Pratik.
Yes, sir.
16. Dhrutik. 16. Dhrutik. Dhrutik absent है या present है? 29. Ayush.
Yes, sir. Ayush.
Sir, 16 present. My mic was not working.
ठीक है, fine. मैंने mark कर दिया आपके present.
Sir, Ayush present. 29.
Got it. 32. Rohan. 19. Ghazi Abbas.
Yes, sir.
4001. Hardik.
Yes, sir.
4002. Sanjay.
Present, sir.
4003. Manav. 4004. Vivek Kumar. 005. Vasu. 6. Tejas.
Present.
Present, sir. Sorry,
005
present.
005 Vasu present है.
Yes, sir.
Vas-
Yes, sir.
7. Manan.
Yes, sir. Present.
8. Yatin.
Yes, sir.
9. Kushant.
Yes, sir.
10. Deep. फिर से 4001 श्याम प्रदीप.
Yes, sir.
4002 Ria. Fine. Anybody else remaining in this class? Guys, this is last call. Anybody remaining for the attendance? Fine. TD1 people can also leave. अटेंडेंस के वक्त किसी को भी एंट्री नहीं है.
सर, रिया का माइक वर्क नहीं कर रहा है, वो उसने चैट बॉक्स में लिखा है.
ओके. रिया बोस्मिया, रिया बेटा अपना नंबर लिखो यहाँ पर चैट बॉक्स में, अपना पूरा पूरा रोल नंबर लिखो रिया। ठीक है बेटा, आपकी अटेंडेंस कंसीडर कर लूंगा मैं।